Good morning, Lindsay. I've started this video twice before and the computer keeps stopping the recording. So let's hope it works this time. Okay, so we're going to go through right now. You asked for help on number 1 and number 2, so we'll go through those. And then 5 and 6 also aren't correct, so we'll go through those. Okay, let's start with number 1. So we want to find the absolute max and min of f of x equals negative 2 secant of x between negative pi over 4 and pi over 3. I have a feeling what's happening is when I switch to the unit circle, it's not working. So I'll tell you what the unit circle says, and then if you need me to help show you tomorrow actually in class, we can do that as well. But we're going to try to make it so this recording doesn't stop. So first thing we do here is take our derivative, which will be negative 2 secant of x tangent of x. And we want to set that equal to 0. Now since this is kind of already factored, we would set secant of x equal to 0 and tangent of x equal to 0. And we really just want it on this interval between negative pi over 4 and pi over 3. Now secant of x is never equal to 0. It's 1 over cosine of x. And whenever you have a fraction like that, the only way it's equal to 0 is if the top is equal to 0. Well, 1's never equal to 0. So that doesn't give us anything. So tangent is equal to 0, the same place as that sine is equal to 0. So if you look on your unit circle between negative pi over 4, so that would be going down, you can't see my hand movements right now, going down to the 4th quadrant to where the pi over 4 is, and then up through pi over 3 in the 1st quadrant. The only place where this is 0 is at x equals 0. So this is our only critical value. Okay, so we need to test our 2 endpoints. So in the original function, the f of x equals negative 2 secant of x. We need to test our 2 endpoints, negative pi over 4 and pi over 3, and then our critical value 0. So negative 2 times secant of negative pi over 4. Now, how you would do this is you would go to the unit circle and you would go to negative pi over 4, again that's in the 4th quadrant, and secant would be the reciprocal of the x value. So you'd take the x coordinate, which gives you cosine, and you would flip it. So in this case, we'd have negative 2, and then we'd have 2 over the square root of 2. Now if we rationalize this, we're going to get negative 4 square root of 2 over 2, which we can reduce to be negative 2 square root of 2. Okay, and you can put that in your calculator to get a decimal approximation. So then for f of pi over 3, so we'd have negative 2 times secant of pi over 3. Now secant of pi over 3, cosine would be 1/2, so secant is 2, the reciprocal. So we'd have negative 2 times 2, which would be negative 4. And then for 0, we'd have negative 2, secant of 0. Cosine of 0 is 1, so flip 1, it's still just 1. So here we'd get negative 2. Okay, so negative 2 is actually our maximum here. It's the largest value. So we'd say a maximum of negative 2 at x equals 0. And negative 4 would be our minimum value at pi over 3. Okay, the video hasn't stopped yet, so we're going to keep going. Okay, so number 2 here, you actually have correct, but we can talk about it. Oops. So 2 here, our function is cosecant of x, so we'd want to take the derivative. So our derivative here is negative cosecant squared of x. So we want to know where that's equal to 0, which is going to be the same place where cosecant of x is equal to 0, which cosecant of x is 1 over sine. So again, this is never equal to 0. So we don't have any critical points. And let's actually look at negative pi over 2. Guess the unit circle in the problem. Okay, and negative pi over 2, which would be down here, we'd have sine over cosine. So negative 1 over 0, which would be undefined. So at our endpoint, we have an asymptote. And what was the other one? 3 pi over 2. At 3 pi over 2, oh, which is actually the same place. We're still undefined. So since we don't have any critical values, and at the two endpoints we have asymptotes, we don't have any absolute max or mins. Okay, so we're going to come to number 5 here. So it says identify the local and absolute extreme values, saying where they occur. So you want to take the derivative and set it equal to 0. I'd already accidentally flashed the thing. So it looks like you have the right minimum. It looks like you're missing a maximum. So look back through your work, and we can look through it tomorrow as well if you need to. But see if you have a critical value at 4. Okay, let's look at this one. Okay, so same type of problem. Okay, so you have the one at 0. You have the one at negative 4. It looks like you should also have a critical value at 0. So check on that. Okay, so send me if you have any more questions. I hope this helps. I'll see you tomorrow.